Okay, so from last session, we didn't do the REST project, right? We just go over it quickly. I'll build it in uh, right now, not some old project or anything. Okay. Then just a small introduction to databases, and we'll install XAMPP. Uh, okay, XAMPP is sort of like a uh, combination of a server, a database, DBMS, and environment to work with PHP and Perl as well. We'll get into that in detail, but we'll see how to install it today, and we'll work on it in the Saturday session. All right. So before we get into it, you guys have any doubts from the previous one? I guess we saw this as well. We went into a bit deep into the REST concepts. So you guys have any doubts from that? Okay, I've uploaded the wrong one, but okay, I will change this. That's my bad. Okay, we'll get into that CSS part. I'll just take these topics and then I've actually written down. I'll show that as well. Okay. Yep. Good. So if you have any doubts, just feel free to stop me in between, uh, and we can discuss that. So and just wanted to update, like I didn't yet share the Notion page for the session 3, the REST API, and uh, the repo as well. I will do that after this session, including for this. So you guys can take a look at the resources as well. And at the end of this, I'll just give a small task. It'll be similar to this with a small modification. And since I haven't shared the Notion page yet, you can take a week's time to do it. So it's totally cool to take a week time because I didn't share the resources. Okay. And I will also review the first task by this weekend and I'll let you know how it is all right. So starting with the project, the REST API project, we learned what are the patterns, what are some rules when it comes to writing REST APIs. It needs to be plural. The HTTP verbs need to be used properly when writing responses. You need to put proper messages and proper status codes. All these were some of the topics we covered, right? So let's just see how we can use those concepts to build an actual backend project. So uh, there's obviously management systems out there much better than what we'll build. But just to understand, we'll take a look at a simple one. Okay. So the purpose of this project is to basically view students, create new ones, create new students. Okay. Then update existing ones. Existing ones and also delete all students. Delete delete all students, right? That's up to us how we define it. Okay. So what details of a student we'll actually be storing? We'll try to save the name, department, and register number. Okay. So whenever you're storing something, for now, make sure you have some value that is unique to each student. There may be many Shivas, many Subramaniams in the college, right? But every one of you will have a unique register number. This is what is used to differentiate you from a person from a student who's having the same name as you, right? That guy can also have the same department. So we need something unique in order to do special operations on it. We'll see what are that in a while, okay? So in terms of features, let's try to define this in REST concepts. So to first we'll need to create a student, right? Initially our data of students is completely empty. So we'll just put /API/students and we want to create one, right? So we learned that this is a post method. Then suppose say we want to read all the students, get a list of all the students. We can follow the same convention, but instead the method in which we are calling it, the action that we put will be different. So it's a get. Suppose say I want to read only one student. So I'll just put API/students/ and here I'll pass in the register number. You notice that I put a colon here. So colon, and then this one, it means that this is a request parameter. Okay, so just keep a note of this term, request parameter. Okay, parameter, as we know, like how you generally pass variables into a function, right? They can depend on various different factors. Same way here, this part can be dynamic. It can be any register number here. So I want to read the data only for this student with this register number, and it's a read operation, right? So it's a get request. Then suppose say I want to update the student's name. Okay, so slash API slash student. Again, I'll pass in the register number, but then here I'll just put name. So can you guys have a guess? Which method will this be? Which HTTP method? Will it be put or will it be patch? I'll just give you a small hint. So even though if we want to update only one field, we need to send all the data. But in patch, I can only I can I have the freedom to update only one single field without having to worry about the other fields. So can you get which one will I use here? You can put in the chat as well. Yeah, that's right. Absolutely right. Patch request, because in this request, I'm not going to be sending the department details. Though I have the register number and the updated name, I have no reason to update the department. Okay, so it's a patch request. And finally, I want to delete a student. So that would be the same way, API slash student, and then the register number. And this will be a delete request. Yeah, sorry, my bad. Keep it plural, okay? So these are the features that we'll work with. It's like 5 API endpoints. And yeah, let's just get started with it. I hope everybody is familiar with the flow so far. I'll install Express and move on. Uh, yeah, okay. After setting up the script, just require the Express module. Just a second. Then we'll initialize the Express application. And then, yeah, the middleware, right? So app.use express.json so that we can pass the requests which have application.json in express.url encoder extended as so this can pass the form requests, form submissions, right? And then let's finally go and let's just, create our own custom middleware also. Just call it request logger, which you can request response and the next function as we discussed in the last session. And we'll just require console the method and along with it the the request URL as well. So we get an idea of which request comes in our console. So request dot method. We just put request dot URL, and we can just use this. Okay, request logger, as simple as that. Okay. And obviously call the next function so it can get on with the next handler. Finally, before we get to the actual app implementation, let's just start the server. So app.mission, port 5000, then a callback stating that the server is running. Something that I usually like to do is directly put this one localhost and then just put 5000. So this creates a URL in the terminal, so which I can just control ticket. So this, for example, npm start. So with VS Code, you have this control flip feature, right? You see it open up here directly, and it since there's no / get route defined, it put cannot get, and it also console here what route and what method the request came at. Cool, right? Okay, so let's get to the actual student management system. And since we haven't gotten into databases yet, we'll go under a lot of assumption. So imagine this is my students collection or something at the moment, and all my students will be an array of objects. So to make this a little bit more easier of how we can create students, I'll just create another file called student.js, and over here I'll just create a class student with a constructor function. Okay, if you remember, classes are nothing but blueprints for objects. We have cars, and cars can be of many types, right? But all the cars have some common properties: four wheels, steering wheel, obviously a hood, then brakes, accelerator. All these are common properties, but the way they are individually defined, right? The different color, the different wheel type, all those are how we initialize and instantiate an object. So classes are nothing but blueprints. I hope you all remember this. And we are creating a student class because there can be many students who have different uh, uniqueness, but they have the same common properties. What is the name, what is the department, and what is the register number in this case, right? So we'll take them as parameters, the name, the department, and the register number. And we'll assign it to the object that will be created from this class. So you have to use this keyword, this dot name is name, this dot department is department, and this dot register number is register number. Cool. And let's just export it. Coming back to my index.js, I'll just import the student class from student is equal to require, and this is a custom module, right? So we need to go through the path. All right, so let's see our features requirement. We first need to be able to create students, but right now we don't have anything to check with. I'll open Postman just on the side. And let's just start it, okay? So, yep. App.post to the /API/students. Request response the handler. And then over here, what I'll do is I'll just extract the data name, department, and the register number from the request body. because I will send it as a JSON object from my Postman. And what I can do is I can just put const new student equal to new with the class. And then you can see it's giving me these things already. Let's just follow the same convention. So name, department, and register number. We'll pass these in. Okay. And then we are assuming that students array is temporarily our database. So we'll just do a simple push with a new student. Okay. And once this is done, let's just response or status 201. Why 201? So I'll just hover over this. You can see 201 means created. We basically a new student was created in our database, and we are responding to the client, letting them know that hey, this operation was successful. The student is now part of the database. As you please go on assumption, this is pseudo database, not tier one. I'll just use the word database for now. We'll get to what those are, but just go on assumption. Okay, and this simple JSON response message student creator. Let's go to Postman and let's try this out. I'll just create a new collection called student manager. Okay, and inside that, I'll just put a new request. The request create student. It's a post request and the endpoint localhost 5000 /API /students. Okay, save it, but I'll go to my body, raw, and a JSON, and over here I'll start entering the details. Okay, name, department, EC, and then register number as RA 20. Okay, I'll send this. Just a second. EPNTS. Logos 5000. Okay, this is getting it here. And yeah, so I got a response, student created, and if I come to the console, so it came to that one as well. Now just come to your Postman, and these are some things we actually didn't cover. So we send this data through the request body as a form of JSON. And once it was successful, we got the message. We know this because we just created the endpoint ourselves. And along with that, it gives you various other things. What was the status? You can see created 201. How much time did the request take? In this case, it was a small one, so just 30 milliseconds. And how large was the response size that we got? Okay. So right now, what is going to happen is when I restart the server, the student I just created is going to get erased from here. So yeah, that's because it's an array, right? Every time we restart the server, whatever previous data was that, it won't come down. All right. So we'll have to keep creating until we are able to get the student. So let's just continue with the next part. That is to fetch a student. fetch all students list and fetch a student by the register number. So we'll just put app.get dash API slash students. Notice that I won't have to change the endpoint because I'm using a different method. So it already knows, it can differentiate. This is for post and this is for get. All right. So just in this case, I'll just do a return, just a response dot status 200 with a JSON, maybe like a message, all students fetched, and pass in the students array directly. Similarly, let's not save it yet. I'll just create a method to fetch students by the register number. So this part is kind of important. Just take a look at this slash API slash students. If you remember, we defined it by the parameter of register number. So parameters in the routes are defined by colon. So just come to your code, put /colon register number, and then your function handler. And to access it, just like how you have request.body, you have an object called request.params. So just put const register number equal to request.params. Right? You see, it's a defined one. It's not something new. It's already a part of Express itself. Then what we need to do is we need to find the student by the register number. So it's as simple as using the higher order function called dot find on the array. So just const student is equal to students dot find for each. There is good for example for now. Okay, if the student dot register number is equal to the register number in the request params, it will either return me that student as an object or it will return me undefined. So those are the two types that I can have for this particular operation. So let's do a conditional. If student is there, then response dot status 200 that we found the student, and then just put the JSON response message student found, and just send the student itself. If the student does not exist, then put response dot status 404 with a JSON message student does not exist. Okay, so let's just take a look. If the student is there, send the to the client or to the postman in this case that we're using that the student is there and passes the object. And the else condition, you can see that the status is 404. 404, all of you are aware, is that when we go to a page and that page does not exist in the website, it just shows like, hey, you're in the wrong page, you've lost your way or something. But it does not have to be limited to a page. It's also for resources as well. You can see if I hover over it, this server can't find the requested resource, not this page. It can be a object, it can be a XML file, anything. Just 404 for something that does not exist. And the message over here obviously cannot find the student. All right, so let's test it out so far with what we built. I just create a duplicate for this. Okay, so this I'll create two students. Another one, there's 52 and location with 53, and I just put this as CSC send. Okay, so there's no way we can check it here, but we can see the request have went through. Now we'll use our endpoints that we created. The first one is to get all students, so we just change this to get request. Okay, send this. Yeah, get request. Yeah. Is current. Just give me a second. Yeah, just remove the body part. We won't need this. Mm, yes. Yeah, some reason it's starting. Okay, good. Yeah, we're getting it now. I had to restart. I don't know why. But yeah, let's just create two, three more students. Just a second. So I'll come back to get send this request. You can see now there are three different students with three unique register numbers. So one is to a CSE, one is EC, all that. Okay. Let's just now let's try to create get student by register number. And this is a get request. And what you can do is Postman has this cool feature. You can just put colon and here like a the parameter. It's usually called a path variable as well. And you can see it automatically added over here for us to put dynamic variables without having to put it over here again and again. Right. So for now, I'll just send an empty value. It gives the student does not exist because I didn't really put a register number, right? I just put one that doesn't exist now. I'll take one from here and I'll put it over here. Then yeah. So see, it brought for you that specific student back. Suppose say I put 54. 54 does not exist in the date in my students list. So it should return me student not found. Yeah, like with the status for not found. Okay. Any doubts so far, guys? With these three methods, we basically just did the first two parts of CRUD operations, create and read. Just let me know in the chat box, or you can unmute as well. Cool, cool. Okay. So next part is basically the updating a student details using the patch method. So it's like API students, the register number to identify which student we are updating, and that we are going to update their name, right? So let's just create that after get slash sorry patch, and it's a slash API slash students, students path parameter register number, and you're going to update the name. So we'll make that clear. Then pass in the handler, request handler, and it's the same thing. So first we'll extract this one from here. Okay. And here we'll try to do another method. We'll use the yeah, let's just do a map method to transform the user, I mean the student. So let's see updated list. Uh, One second. And from that, let's just it's a constant, right? So we'll need to update that in order to reassign. Right? So equal to students dot You won't even need to put updated one, just a simple students. Students.map, okay, for each student. If the student dot register number is equal to the register number in the path, we'll also be sending the updated name in the request body. Okay, so we'll extract the name. If the register number matches, then for that student, update the name with the new name, and by default return student. So if the register number does not match, it's not going to update the name. It will be the same. And once this is done, we'll just response dot status 200 with a JSON or message student updated. Correct. Similarly, let's just create a delete request as well. So app.delete, the delete method to the student's endpoint. Make sure you take in the register number as a path parameter and then pass in the request handler. And over here, we can use the same approach as finding a student, but instead of this, we'll just do find index. Okay, so find index, what it does is it looks for an array of objects. It checks if the register number exists. I mean, there's an object with that same conditional, and it will return at which index is the object in that array. All right. So here also we can check if student is greater than this is just student will rename this. This is the index, not the student object. Okay, so if the index is greater than -1, if I'm not wrong. Yeah, it's greater than -1, meaning if the student does not exist in that array, the find index method returns the number -1. If it's that, it will return that specific index. Okay, so we'll use the students dot splice. Start number will obviously be that index, and the number of elements we're deleting is 1. Okay, else this would return response dot status 200 with the JSON message student deleted. And if the student does not exist, we can return the same message. 404 student does not exist in the else condition. Okay, save this and yeah, let's test it out right now. I'll just create a student first. Okay, let's try to see if they do exist. Okay. By specific number, it's that. And let's try the patch request first. Okay. This is a patch request, and my body, I'm just going to send the name, updated name. So here I want to put the full name. Come to my headers. You remember we should pass the register number and the name, right? So here we didn't actually put any check for the patch, but generally it's a good practice to put checks like this to check if what you're going to update is actually part of database before actually interacting with it. Okay, so make sure that you do add some checks. But for now, we just put the correct register number. And this and student updated. If I want to check it I'll just go here. And you can see now it's the full name. Even if I come to this one, if you remember, this one had only my first name. Now, if I send a request, it should return my full name, right? So the patch request works over here. Now, similarly, let's try the delete request as well. Delete is similar to the endpoints in get. So I'll just duplicate this. Delete student. And this is a simple delete function. And make sure that you send the register number. For now, let's not put anything. Let's send it. It should give me student does not exist. So now if I put the right register number, send this, student deleted. So now if I send the request the second time, it'll give me student does not exist because we just deleted it, right? So it's working just as we expected to. Let's go to get all students, send, and you can see it's not there anymore. Cool, right? So with this, you basically just created a the basic REST API with the full CRUD functionality. All right. Any doubts with this? Yeah, just feel free to unmute and ask as well. Both way works. Cool, cool, cool. All right. Yeah, I hope this is totally fine now. So now let's just get out of our pseudo database over here. Let's just see what we can learn with an actual database now. There are a lot of inconsistencies with what we did just here with this simple list. Okay. So the first one, I mean, we just noticed it, right? Whenever we restart the server, we are losing all our data that we previously saved. So that's not good, right? Having your database as part of your code is the worst possible way to actually store your data. So that is why we have databases and DBMS, database management systems, so that we don't lose the data along with various other required features that makes it easy to manage information. Okay. So first of all, what is a database? Database, in most simplest term, it's an organized collection of information or data. Yeah. So it's an organized collection of information or data, meaning the way you save it, the way you view, how you present it is all presented in a very neat format for you to utilize in a very efficient way. Okay. Yeah, I mean, this was what we saw, right? One other alternative is we can just create a, I don't know, a JSON file, something like that, db.json sort of thing, and we can store it here as well. Yeah? Since this is a part of file system and it's not part of code, we don't have to worry about it being deleted. So you could consider this also as a database, but it's not actually one. It's still far from it. Okay. So if I use a db.json, I can save as it an array of objects over there also, but we come up with these issues over here, mainly these 5 ones. We have inconsistency issues, meaning there's no way to verify whether one object has a specific property or whether the other object missed it out or not. It's really tough to do it when you have when you're using a JSON file, for example. It's it will become really big, right? As the number of users in your application grow, you'll have many number of objects. Are you going to take the time and sit to verify everyone has the same properties? No, right? So when you're using a JSON file, it brings up lots of inconsistencies. It's not necessarily limited to JSON. You can have your Excel, CSV files, all those as well. I'm sure people learning machine learning, you have to use the, I guess, pandas, no, to uh, make sure that you remove the inconsistencies from your data set, right? Then you also face redundancy in your data. Basically, some fields, even if the fields are there, some of the fields data will be missing, while other fields will have the data. So you have some missing parts in your database. Imagine if for the same students database, the register number is the unique part, right? Without which we cannot identify or do complex operations. So the register number is mandatory, but if you're using a JSON file, it will be really tough to tell whether a field is empty or whether that field is has some value or not. Okay, then obviously you have some accuracy issues. Some fields uh, may have a specific data type. When you come to your JSON, your data types are very limited. Only string, numbers, obviously arrays, objects, those are also there. But then when it comes to data types like dates, then it becomes an issue. You cannot exactly store dates. You can store it as a string, but then later you have to parse it. It's not a native type in JSON, right? Then you obviously have security issues. If I'm going to use my same uh, file system as my server, and if there were complications in my server itself, then obviously any file in the same file system is going to be affected by it. So there's a huge security complication, and obviously the scaling issues. As we just mentioned, imagine there's going to be tens of thousands of users or students in this db.json. In that case, uh, if I'm going to use this array methods, right? Dot find index, it it has to go through one element after another. If I use a normal for loop, it's going to have a O and complexity, right? It will take uh, the O and for 10,000 elements is going to pass through each and every element before I get the right right one I'm looking for. Even though in JavaScript, these methods, right, they have a O n log n complexity, because I guess under the hood they use various algorithms, if I'm not wrong, like binary search is one of them. So you'll have to learn various algorithms in order to optimize the way you search data in a file such as this, the JSON file, when you're using for a long number of entries. So having it in your file system, your database in your file system is not the best way to go forward, right? That's where database management systems come in, DBMS for short. Okay. Don't confuse it for, don't mix up the words. Okay. All right. And yeah, so that's where these systems come in, database management systems that solve these issues. So before you put data into a specific DBMS, it will verify whether those fields are there, whether those data types match, whether they're empty or not. All these are taken care by DBMS. You don't have to do any sort of verification on your side. Uh, then obviously they are more secure because they are hosted in a separate location, and you need specific credentials or specific IP access. Also, you need to specify, which makes it more secure. And these database management systems, they are easily scalable because the way you suppose say I did dot find now, right? In their system, they have already implemented the best of algorithms, best of indexes for you to able to find uh, a one entry from thousands of objects. So all these are taken by a proper database management system, and that's why we prefer to use them over having the data in our same file system. So in general, there are two types of DBMS that you'll come across: relational and non-relational. These are the topmost categories. Obviously, there are other types also: network-based, hierarchy-based, all that, but those more or less can be categorized under these. You don't have to get too complex now. Just know that there are two types for now: relational and non-relational. Okay. So in relational, you basically have table type of structure. You have a defined way of storing data. And obviously, if you have a way in which your data is organized, reading them will become much easier. And one of the main advantages of relational databases are they have foreign keys and primary keys. I'll show you what they are, but we'll go into that into detail in the Saturday session. All right. So as I said, they are of table format. So, and in a table, you obviously have your rows and columns. See, so these are your rows, these ones, sorry, my bad. It's the other way around. These are your columns. Okay, I'll just put it as C. And then in your column, you can have many rows, right? Okay. These are your rows. I myself got confused there for a minute. Okay, so your columns are basically your fields. That's what you call them in a relational database. And your rows are basically called your records. Okay, so your fields are common properties for, for, for each of your records. So example name, my department, and my register number, right? So all these are fields because they are common for all of my entries that I'm going to make inside my uh, database. And rows are basically entries, right? Entries or records. So here I can have Kunal, department, EC, reg number, that 51. Like this, I can have many entries over here. Now, suppose say I want to relate each student to a specific, say for example, subject or a course. Like you have electives, right? You can enroll for elective, but you cannot be in many electives at the same time, right? So over here, say I have my elective course ID, that 18 EC, or for some of you it will be 20, I guess now. Your course code, your course name, and then probably I don't know, maybe the credits. Okay. So all this is in another table. So what I can do is I can create a relation between my register number, which is unique, and the course code, which is also unique, and tell that, hey, this student has taken this course. So make sure there's a relationship between both. So I can create obviously one more field over here called the course ID or something. I know here I can create another one for the student register number to keep a track of which student has taken the course. So what this will do is it will create a relationship. In this case, my register number is the primary key for my students table, and the course code is the secondary key or a foreign key. Please use the term foreign key, not secondary, that's wrong. Okay, so what it does is it creates a relationship. Hey, this guy has taken this course, and in the course table, hey, this course is being taken by this student. So querying data becomes quite easy. Querying basically means querying is another term for request, sending a request. But specifically, when you're sending a request to a database, it's called query. Okay, so you're going to query data over here in a much easier format compared to non-relational. I'll show you in a while. Since the relationships are defined over here, it becomes easier. Syntactically, we learn it in Saturday. So right now, don't worry about understanding this specific concept in depth right now. Okay. Then we have non-relationship databases. So these can be of any formats, objects, XML format. These are two most common ones you'll see. It's not usually of table type, so you won't see tables over here. They have a flexible schema, right? When I'm creating a database in relational databases, my fields need to be set. Then I have to create my table, then only I can add data. Whereas in my non-relational databases, I don't have any table format, right? I can directly add uh, any property, any value. It can be organized or unorganized, just like that. Just like how in an object you can create a key randomly, same way I can add any property directly to my non-relational database. That's what flexible means in this case. Yeah. And then over here, write operations are more favored because I'll show you in a while. Let's just take a look at the read part first. So now over here, you store objects in terms of collections. Better to, if I type it up, my handwriting is not good. Okay. Obviously, I have collections. In my collections, I can have various different types, various different types. So I have a student collection. Collections are nothing but you can call them as list as well. And then I can have a course collection, right? So over here, for me to relate one object to another, there is no direct relationship, right? Even though I can put an ID, it's in two different locations altogether. So I'll have to make multiple queries to find the same sort of data. Whereas in my non-relationship, I mean relationship databases, they're already related. So just one query works to get all the data. These are usually called your join queries. It left join, right join, all these we'll see in Saturday. It's really cool stuff that makes working with relationship the relationship databases much easier. Okay. Yeah. I mean also like why some additional advantages of using database management systems, right? If I haven't convinced you yet, we have things called replication. We have some things called uptime. We have something called sharding. These are all additional things that various DBMSs offer. Replication basically means it will create more than one copy of your current database in various locations around the world. So if one copy goes down, you still have maybe two or three additional to back up on. Then uptime means uh, it will always run 24/7 if depends on the provider. They promise that it will be either 99.99% time up. So they promise that your database will run almost all the time whenever you need it without you having to wait or something going wrong on their end. Then you have something called sharding. Sharding basically means you split your databases into small parts, and those small parts will help making the querying easier. So there are lot of more advantages that DBMSs offer that we don't have to get into now, but just know that they are really cool when compared to trying to store data on your own file system. Okay, I hope I've convinced you why to use DBMS. Okay, any doubts with this so far? Basically done with like the very basic introduction. We'll take a look into these two in the Saturday session, but we'll do the setup for it right now. So we'll learn SQL, specifically working with the MySQL database management system. And then we'll take a look at MongoDB, including the MQL. So like how you have SQL structured query language for relational databases. You have various languages in the non-relational database side. So MQL is one of them, Mongo query language, you have GraphQL, all these various types are there. So we'll just start with MongoDB, something simple, something straightforward and easy to learn. And we'll use MongoDB Atlas, which is similar to your MySQL for storing our database in MongoDB. Okay. So any doubts so far, just let me know. We can move forward after that. Okay, I'll just take that as a no doubt. But yeah, feel free to ask me in the later time as well. So yeah, let's install XAMPP. So XAMPP full form basically stands for X operating system, meaning not necessarily it has to be Windows, Linux, or Mac. It works in all three. Apache is basically a server, like how you have ngrok. Apache is a server that hosts your files. MySQL is a DBMS. PHP and Perl are languages. So this XAMPP allows you to run these two languages in its server environment. So basically, we are installing a server in our local system for developing applications in this stack as of now. Obviously, we won't get into PHP, but this XAMPP does support this specific stack. Popularly, you will see WordPress run on this ones. WordPress is a huge chunk of the internet. It uses and MySQL mainly. And yeah, so let's just get started. Just go to this link. I'll download with you. I haven't downloaded myself. I did download while I was learning, but I had to delete it a while back. Okay. Yeah, so let's go with the latest version itself. Just download it. It's about 150 MB. Give me a minute while it downloads. Yeah, I mean, okay, before we actually download it and see how to use it, this is the main purpose. Like, we'll use the MySQL DBMS to learn how to work with structured query language, and then we'll use the same DBMS to connect our Node.js applications to their DBMS to store our data. All right. So these are the two main reasons why we use it. We're not going to take a look at PHP or any other things. Okay. So it's downloaded. I'll just open it up. This for the I mean, yeah, this depends. If you want these FTPs are basically file transfer programs. Like how you have your FS, you have similarly FTPs to work with your file systems that are located in other environments. Then you have your Mercury mail server. This is SMTP. SMTP stands for Simple Mail Transfer Program. So those are for how you send your emails to your Gmail, Outlook, Hotmail, all these. So this also facilitates you to send email from one client to another. So we won't be needing them right now. So maybe you can just take them out. Leave it totally up to you. Yep. Yep. Just keep the default settings. English, yes. Yep. Cool. Okay, while this works, there was one question from Deepak, a really cool one. How do I serve my CSS? If you link your CSS file to your index.html, but then when you actually load it up, the styles did not appear at all. Okay? Let's see it here itself. I'll use the same server. I have my index.html over here, and this is simple h1 I like this. So if I come to my index.js, let me just create a endpoint to server app.get slash request response, then 10.5 index.html. So I'll just go to the page 5000. Yeah, my bad. Index.html. Uh, yeah, my bad. I keep forgetting this. It's taking your absolute path. So absolute path means from your system's path itself. So you need to make sure that you include that as well. From the directory name, meaning from which drive it's coming from, to index.html. Just come back to this. Yep. Okay, it's there here now. But let me try linking a external CSS file. CSS. Here I'll just put h1 color and save this. Go to my index.html and I'll just link the style sheet. Okay. This- Save this. Cool, cool. Okay, so let's just see if this works. It's not coming, right? My styles are not getting updated. Uh, and if I go to my console, it should show that hey, styles.css is not there, not able to locate it. So what you need to do is you need to actually set up something called static files. CSS, JS images are all your static files. So you need to tell Express that, hey, these files also need to be served for every request that you make, but you cannot keep making individual endpoints, right? So you just use app.use express.static, and this one takes the path to your file. So just put path. It's the same file, right? So I'll put this. Okay, it's working now. So if I reload it, now we see now the color is updated, right? So you need to make sure that you're serving a static files as well. And you can do that easily through the middleware called express.static. Okay, I guess XAMPP is installed. Let's finish this. And should be here. Right, so, oh yeah, that. Okay, so you'll have a control panel like this, where you can start various services that you download. Since we didn't want FileZilla and Motif, we excluded that. So these are the two main ones you're looking for, Apache and MySQL. Make sure you start both. Okay. Once this runs, just click on admin. It'll open up the PHP MyAdmin part. So this is basically your SQL DBMS. You have various tables, and inside, sorry, you have databases, and inside databases you can have tables. Yeah, sure. Deepak, anytime. Okay. So yeah, let's end it for today. That was it for all. Uh, just let me know if you have any doubts later. Okay. So one before you close it, make sure you stop both. It's important. Otherwise, it will keep taking up processes. Cool. Yeah, that was it for today. Just let me know if you have any doubts later. Cool, cool. Sure, guys. Yeah, I'll see you in Saturday then. I'll share the Notion page so you guys just take a look at it. Cool, cool. Thanks for coming, guys.
Thank you. Bye.
Yeah, bye man, take care.